Since 2004, the Saudi Commission for Tourism and Antiquities and the German Archaeological Institute have been jointly conducting excavations at the ancient oasis of Tayma in the northwestern Arabian Peninsula. In addition to scientific research, preservation of the excavated artifacts and buildings, employing long-term conservation measures, is an important aspect of our work. In the last years, we have learned that Tayma was an extremely important location in antiquity, involved in supra-regional, political and cultural developments. We also know that Tayma was a crucial partner in international networks, and these are being further studied as part of our research. Our most relevant findings include evidence that the ancient oasis dates back to at least the 3rd millennium BC, meaning that an oasis economy was introduced at that time, at the latest. Another finding is that this settlement assumed a significant role in international trade not later than the 2nd millennium BC. Tayma was, so to speak, a hub of international commerce for trade within today's Near East. Other important discoveries, like the architectural remains of various settlements, must of course be left in place and be made accessible to scientists as well as visitors. In this context, the restoration of the architecture is an essential precondition. The preservation plan devised for the Tayma site specifies a concentration of effort on a few selected buildings. The temple you see here behind me and a residential unit. The top priority is to preserve the masonry by applying 3 specific conservation measures: sealing joints, arranging for rainwater drainage for the wall crowns, and repairing damaged sections of the walls.
After archaeological documentation has been completed, the walls will be conserved in the condition in which they were found during excavation. No ancient remains will be reconstructed. Gaps in some parts of the walls will be filled when this is needed to ensure their stability, but this kind of intervention will remain recognizable. All measures are carried out using a modified mud mortar that has been previously extensively tested in the same environmental conditions. The dry mixture for the mortar is composed of sand, mud, lime, and palm fibers. All these materials are of local origin and locally available and further processed right at the excavation site. The palm fibers are chopped into small pieces and the mud is crumbled and passed through a sieve. The recipe of the dry mortar is 12 parts sand, 6 parts mud, 3 parts lime, and 1 1/2 parts palm fibers. The dry components are mixed with the help of a mixing machine for about half an hour. Enough dry mortar is produced to meet the needs of an entire conservation season. Water is mixed into the dry mortar just before it is used. This is done manually, first of all because only small amounts of wet mortar can be prepared due to the climate conditions. and secondly, because it is then easier to control its consistency. The mortar is applied when it is relatively dry and has a clay-like plastic consistency. This makes it easier to compress and reduces the risk of shrinkage cracks. The original mortar used in the building joints lost its binding power in the course of natural degradation processes over the years. For that reason, the external parts of the wall joints are scraped clean before the new mortar is inserted. Then, the surrounding stones and the joints are moistened so that a firm bond results when the mortar is applied. The plastic mortar is applied by hand and then shaped with tools. The material is compressed by exerting gentle pressure to fill any recesses in the joints and assure inner cohesion. This procedure is also used for the smaller wall joints. Immediately afterward, any excess mortar is cleaned off the surrounding stones. Conservation of the wall crowns follows the same principles. It is especially important to seal the horizontal surfaces to prevent penetration of rainwater, which would lead to further damage of the wall cores and have a negative effect on stability. Drains are made to keep rainwater from pooling on the wall crowns. Where necessary, the level is raised with the help of small stones. They can be clearly distinguished from the surrounding masonry because of their format. The mud mortar is kept moist for several days after it has been applied. During the first night, this is accomplished with a wet cloth covering, and on the following days by regularly spraying with water. Otherwise, the drying process and chemical reactions would be uneven due to the intensive solar radiation. The next morning, the covering is removed and the surface of the new mortar is dressed. The compacted mortar in the joints is scraped off. Some of it is removed in order to enhance the visibility of the masonry.
Beside work on masonry, installations and architectural elements like column bases, water cisterns, ovens and stone-paved floors are also conserved.
Special conservation measures are devised for these architectural elements, according to the guidelines of the overall conservation concept. This is only done after the completion of archaeological documentation. Only in exceptional cases are installations or architectural components temporarily dismantled for treatment. All stages of the conservation work, including materials used and techniques employed, are systematically documented with the aim to keep record of the undertaken measures for future reference. This includes describing the situation both before any work was started and after its completion. Most of the restoration of installations and important construction elements are carried out in situ, in other words, at the location where they were found. Special restoration materials imported from Germany are used for these measures. They are all highly performing and durable, and wherever possible, the restoration measures are reversible. Conservation work usually takes place in the autumn after the spring season in which the excavation was carried out. The team of restorers is composed of graduates of the Universities of Applied Sciences in Berlin and Potsdam. The overall strategy and each measure are discussed extensively and agreed upon by both the conservators and archaeologists of the interdisciplinary team.
Work begins with a careful analysis of the masonry. Damage is systematically recorded and mapped. At the present stage of the project, monitoring plays a large role. The restoration measures are regularly and methodically checked for their durability under the climatic conditions in Tayma. This is a continuous process, scheduled to take place over many years. In order to illustrate the extent and effect of the restoration measures, so-called archaeological windows have been left. They allow seeing how the masonry looked like when it was discovered. The transition between the two areas can be clearly distinguished here at the borders. This is the restored area, and over here the condition of the masonry when it was excavated can be seen. We assume that the walls were originally coated with a layer of plaster. Numerous objects have been removed from the excavation and placed in museums, where they undergo conservation treatment. We have now started to implement a concept for long-term storage of these objects after restoration, so that after the excavation is over, all objects will have been expertly prepared for long-term storage. These measures are embedded in a concept for preparing the site for display and making it accessible to the public. Routes for tourists and visitors are planned through the site and within the ancient buildings. The scientific results from the archaeological excavation will be presented using text and image panels as well as digital media. By this, we do hope, on the long run, to not only contribute to the preservation of heritage of this part of the world, but also to return those parts of history we have been working on to future generations.